Speciation. Now, in order to understand speciation, we need to understand the definition of a species. A species is a population or a group of populations whose members have the potential to interbreed with one another in nature and to produce viable, fertile offspring. So, for example, let's take a species like this and call it a cetane. Here we have a population of cetanes running about in the wild. Now let's say that a meteor hit the Earth. This would cause the two land masses to break apart, forming a geographical barrier. Now one of these two land masses might go to a colder part of the biosphere, and another one might go to the warmer part of the biosphere. This would leave the cetanes in the colder part of the biosphere unable to reproduce with the cetanes in the warmer part of the biosphere. And over time we would go from seeing cetanes in this kind of climate to seeing cetanes in these two types of climates. And then, some thousand years later, we would really start to see cetanes adapt and evolve to their new climates. Finally, we would see two different species entirely, a cold climate cetane and a warm climate cetane. These cetanes develop specific characteristics as they adapt to their environment. For example, the cold climate cetane developed flat feet to help it skate on the ice, and the warm fur to keep it from freezing. All this is due to natural selection. But in the end, we have two different species that would be unable to reproduce if they were in the wild. Another term for this type of speciation is divergent evolution. The alternative to this is convergent evolution. This is when two species that live in the same habitat evolve to look a lot alike because they live in the same habitat. An example of this would be sharks and dolphins evolving to look a lot alike because they both live in the ocean. Another example of this would be birds and bats evolving to look a lot alike because they both live in the air. Now let's get back to speciation. Earlier I mentioned that these two would not be able to reproduce if they were found in the wild. Now let's explore why. There are 8 reasons why these animals wouldn't be able to mate in the wild. 5 of them are prezygotic, meaning before fertilization, and 3 of them are postzygotic, meaning after fertilization. First, let's look at the prezygotic mechanisms. The first mechanism is habitat isolation. An example is how these deer cannot mate because they live in different habitats. The second mechanism is behavioral isolation. An example of this is how these two meadowlarks differ in their mating calls, and so thus they can't mate. The third mechanism is temporal isolation. An example of this is how these frogs mate at different times, and thus they can't reproduce. The fourth mechanism is mechanical isolation. An example of this is, well, I think you get the picture. The fifth mechanism is gametic isolation. This is when the sperm of one species won't mate with the egg of another species. Now let's move on to postzygotic mechanisms. The first mechanism is reduced hybrid viability. We see an example of this in a hybrid salamander that cannot physically grow to adulthood. The second mechanism is reduced hybrid fertility. We see an example of this in a mule that is physically unable to reproduce offspring. The third mechanism is hybrid breakdown. We see an example of this in plants that aren't able to reproduce after several generations. If none of these 8 problems show up, we know that the 2 members are part of the same species. Now let's come back to speciation and one of its main causes, natural selection. We can categorize natural selection into 3 different parts. First, we have directional selection, where the organisms in a population grow to have one extreme characteristic. Next, we have diversifying selection, where organisms evolve to have both extreme characteristics. Finally, we have stabilizing selection, where organisms evolve to have medium characteristics. So let's finish this up with a bit of taxonomy. Here we see the domain, kingdom, phylum, class, order, family, genus, and species of a red fox. But the genus and species are how scientists categorize its name.